So here, we're going to learn about one of the main building blocks in programming, functions. So a function is a block of code which only runs when it's called. And that means that we can define a function and everything that we include inside that function won't be executed until we actually use that function. So functions can take in data as inputs, which are known as parameters or arguments, and commonly they can also return data as a result. So let's see how to do that in Python. So here you can see the basic syntax of a function. The very first thing that we need to do is include the def keyword. This keyword tells Python that we're about to define a function. Then we have the name of the function, in this case, test function. And right next to the function name, we've got to add parentheses in which we can include the arguments that that function can take. Arguments, just parameters. So it's important to notice that functions don't necessarily take arguments. So you can have these parentheses with nothing in, just leave them empty. However, when you're defining a function, you must have the parentheses there, even if they're empty. And to finish that first line, don't forget about the colon. So obviously the colon usually means on the next line, I'm expecting an indented block. And that block at that level of indentation is going to contain the code which is going to run when we use this function. And at the end of that code, we can optionally add the return keyword. And in this case, we're going to return this string, which is the output. We can return any data type. So if we don't add a return statement, the function will return the Python none type. So first, let's see some more examples to get a better understanding and go through a few more things. So in the next cell, we've got an example on how to define a function. And notice here that, as I mentioned, we're not passing any arguments to the function. But notice that the parentheses are there, so we just leave them empty. And when I run this cell, nothing happens. There's no output at all. And that's because, as we mentioned, the code inside the function doesn't run until we use that function. So executing a function is super simple. Simply type the name of the function and add parentheses on the end. We call this calling the function. So now take a look at the output, which now reflects the content of the function. So you can see here, I've called the function. So it prints hello, it prints world, it returns goodbye. And one common mistake when using functions is not adding these parentheses. So the parentheses are the way that you tell Python we're calling the function. I'm not talking about the function, I'm talking about calling the function. So if you don't add them, Python's simply going to print info about the function, not actually what it returns or anything inside it. So if we run this, it basically says that say hi is a function, but it doesn't give us anything more, and it certainly doesn't run the code inside that function. So if you're trying to use the code which is inside a function, don't forget to call the function by following its name with parentheses. And it's so important to notice the difference between a function and a function call. So say hi is a function. Say hi followed by parentheses is a function call. So a function call becomes equal to whatever it returns. And another way to say that is that a function resolves to its return value. So if you assign a variable to a function call, it's going to take on the value that's returned by that function. And in the next cell, you can see that where I'm assigning this variable length equal to what's returned by Python's built-in len function. And the examples we've seen so far don't accept any arguments. But one of the beauties of functions is that they can be used with different arguments and return a different output. So really what the code does can depend on how you call the function. And so let's define a function here that accepts some arguments. This one calculates the length of a string, and it's going to return the number of characters in the sentence. So for each sentence, the function returns a different value. And that means that, indeed, the function changes its output based on the arguments that you pass to it. So let's use a similar example here to explain a couple of things about the return keyword. Now we're going to define a function that only returns the length of the sentence if the number of the characters is less than 30. Otherwise, it's going to print that the sentence is too long for whatever reason that might be. So take a look here. The return keyword is in the if statement. So that means if that condition's not met, it's going to print out the sentence is too long, but it's not going to find the return keyword. There's going to be no return hit when that code runs. But if that condition's true, the code in the if statement should run before printing the sentence which says it's too long. However, that doesn't actually happen, because once the function hits the return keyword, it exits the function and doesn't run anything else inside. Nothing below that return keyword is going to be run. And you can see this if I run the cell. So we're calling the function with a sentence whose length is less than 30. The output doesn't print anything related to the sentence being too long. And that means we can see as soon as the function hits the return statement, it exits the function. So let's see what happens when the sentence is longer than 30 characters. In this case, the return statement's never reached. The print statement, on the other hand, will print that that sentence is too long. But what happened to that len1? Well, let's take a look at its value now. The value is none, and that's because, as I mentioned earlier, if a function doesn't have a return keyword, or you don't hit one, it's going to return the Python none type. And when a function doesn't return a value, we call it a void function. So functions stop running as soon as they find a return keyword, but not all functions have to have the return statement in. One important thing to notice about functions is that the variables inside might be affected by variables defined outside of that function if they have the same name. But it doesn't happen the other way around. And this is because of something called scope. So the scope refers to the parts of a program which have access to a specific variable. So here we're going to focus on two kinds of scope, local and global. A variable defined inside a function has a local scope and it can't be referenced outside of it. On the other hand, a variable defined outside of that function, somewhere else in the script, has global scope, and that means you can reference that variable anywhere, including inside the function. So here we define two variables, x in the global scope, y in the local scope, and you can see that when you run this cell, first we define and call the function, and then the output shows that inside the function, Python didn't have any issue finding x, which is in the global scope. And the same thing goes for y. Inside the function, we got no problem referencing local variables. But when we print our variables outside the function, the global variable printed no issue. But when we reference the local variable, which is defined inside the function, it's going to throw an error because Python won't find it. And that's because y is, as I mentioned, it's stored inside the function, that's where it's defined. And once the function finishes running, y is not stored anymore. So when you've got two variables with the same name in different scopes, the local variable will overwrite the global variable, but only inside a function. Let's take a look at one example using x in both scopes, just to see if that's true. So here you can see the global scope x has been defined to 10. So before calling the function, the value is unchanged. And then when you call the function, we're changing the local value of x to 20 as the local value of x. So when we print it, its value is 20. But then when we go back outside the function into the global scope, we can see that the value of x is still the same as it was originally in the global scope. And that's because the local scope won't make changes to the global scope. So by now, you know that functions can accept a number of parameters, but in some occasions, you might need to use functions where the number of arguments is unknown or might be up to the user to specify. So let's say, for example, you want to create a function that accepts an undefined amount of numbers and returns the mean value of them. So creating a flow control for all possibilities would be incredibly inefficient if you had an if statement for 1, 2, 3, all the way up to 100 million. But can we do something better to solve that? Absolutely yes. But I don't expect you to know that. I don't expect you to know any of this. So we're going to Google it and take a look. Let's search here Python functions with variable number of arguments. All right, and we can see the Stack Overflow link, always a good place to look. Let's take a look at the answers. So here's the question. Looks roughly right. Just have a quick scan of that. Go down to the first answer, and first answer says you can use args, star args, to pass a variable number of inputs. And you can see in the answer, this input's going to behave as a tuple. And the way to pass them into a function is simply by adding that value as usual, comma separated. So, it might be worth checking the second answer too. Let's have a look at that. And yeah, nice. It looks like it's got a bit more information which can add to the first answer. So it says we can also use star quags. Quags is short for keyword arguments. And you can see in the answer, these inputs will be behaving as a dictionary. So if you have a function which has star quags in the definition, it's going to take all of the parameters which are passed in as keyword arguments and assign them as key value pairs in this dictionary. If we have a function which is defined to take in star args, it's going to take all the positional arguments and store them in a tuple which is available as args. So let's take a look into that in VS Code and make sure we're clear on what's going on there. So in this small example, you can see that we just added star args to the parameters, and now we can pass as many arguments as we want. And when we're calling this function, it prints out the arguments between parentheses, and yeah, that tells us that we're, as expected, we're dealing with a tuple. We've stored those undetermined number of arguments in this tuple using star args. And just to check that, printed the type of the variable as well. Indeed, you can see it's a tuple. So this might be helpful, for example, if we want to calculate the mean of a sequence of numbers. So this example, we use star args to get a variable number of inputs, add the values in the tuple, divide by the number of items, and then we're able to return the mean. And the second way to add a variable number of inputs to the function will be using the quags argument with a star. And the difference is that apart from the value, we have to pass a key. We have to pass these in as not positional arguments, but as keyword arguments, where we're specifying, key name equals the value. And here you can see that when we get that quags inside, it's going to be acting as a dictionary. Well, it is a dictionary. And we check that using the type function as well. And if we try to pass arguments without any keyword, the function is going to throw an error saying it doesn't accept any positional arguments. So positional arguments would correspond to those which don't have a key equals, and they're expected when we write star args. So let's take a look at this example now, which uses both actually. So here we can see the function, it's got star args defined and star quags defined in the position of where its parameters would be. So since the args is going to be a tuple, here we index it and get the fee, and quags is going to be a dictionary, we can iterate through the items which are going to be its keys. And with that, we can calculate the final value. So one thing just to point out there is that args and quags, that's just a conventional name. You should probably stick to that so everybody knows what you're talking about and it's easy to remember without using a fancy variable name. But you can actually call those things whatever you want if for some reason that doesn't work for you. So let's just summarize kind of what we went through there. We've seen how to define functions, why we might use them, when we might use them. We've seen how to call them, the difference between a function and a function call as well. We saw how to use a return keyword, and we saw that once the function hits a return keyword, the function finishes. And if it doesn't have a return statement, it's going to return none. And anything assigned to a function call is going to be equal to the value returned by that function. And we saw the different types of scope, local and global scope, and we saw how to pass parameters into a function and how they behave in those different kind of scopes. And we've also seen using the star args and star quags syntax to define functions with variable numbers of parameters. And now I hope you're ready to start using functions in your code.